Next we are going to discuss a very important probability density function which is known as normal distribution, otherwise known as Gaussian distribution. This distribution is having wide variety of applications in different fields. Okay, so the probability density function of normal distribution is f of x equal to 1 by root 2 pi sigma e raised to minus 1 by 2 x minus mu by sigma the whole square, where the random variable x ranges from minus infinity to plus infinity, and the mean of the distribution is ranging from minus infinity to plus infinity, and sigma, which is the standard deviation of the distribution, which is greater than 0. We know that standard deviation is always greater than 0. Now we can see what are the important properties of probability distribution, that is normal distribution. So normal distribution is a symmetric bell-shaped probability curve. Okay, and it is symmetric about mu. So as in the picture, it is a symmetric bell-shaped curve which is symmetric about mu. And next property is that its mean, median and mode are equal, and which is equal to mu. So we can say that what normal probability curve is symmetric about mean. And this mean mu is known as the location parameter, because if our mean is here, this curve changes its location. Okay, if your mean is here, so this will go like this. So according to the mean, the location of the normal curve changes. So this is known as location parameter, and sigma is known as the scale parameter. That means as the value of sigma increases, the spread will be more, and as sigma reduces, this curve will be becoming closer. So sigma is known as the scale parameter. And as I have already told you that sigma is the standard deviation, then variance will be sigma square. That is the next property. And another property is that total area under the probability curve is 1. Since this is a probability curve, the total area, when you integrate f of x from minus infinity to plus infinity, you will get the value 1. So total area under the probability curve is 1. Then next property is known as the area property. So before explaining this, let me say one thing. Since this is symmetric bell-shaped curve and the total area under the probability curve is 1, then the probability from minus infinity to mu will be 0.5 and mu to infinity will be 0.5. Okay, so since the area under the curve is 1 and it is symmetric, we can say that probability from minus infinity to mu is 0.5 and mu to infinity will be 0.5. Not only this, if you are having a point here 2, okay, let us take an example as 2. So the probability from 2 to infinity and minus infinity to minus 2 will be the same. Similarly, from mu to 2 and minus 2 to mu will be the same. Okay, that is the property of symmetry. Okay, now let us see the area property of normal distribution. Probability that x lies between mu minus sigma and mu plus sigma is 6825. That is, this is the point mu minus sigma and this is the point mu plus sigma. So this area will cover 0.6825. Okay, this area will be 0.6825, or we can say that 68.25% of the data will fall from mu minus sigma to mu plus sigma. Then next is probability from mu minus 2 sigma to mu plus 2 sigma is 0.9544. So if this is mu minus 2 sigma and this is mu plus 2 sigma, then this whole area will cover 0.9544 of the total area. Okay, or otherwise we can say that 95.44 percentage of the data will fall from mu minus 2 sigma to mu plus 2 sigma. And next is from mu minus 3 sigma to mu plus 3 sigma, we will be having 99.73 percentage of the data. Okay, so from mu minus 3 sigma to mu plus 3 sigma, we will be having 99.3 sigma percentage, 99.273 percentage of the data. Okay, 99.73 percentage of the data falls from mu minus 3 sigma to mu plus 3 sigma. So this is known as the area property, and this property is using in statistical quality control for fixing the control limits or specification limits.